Hello, this is Bergson's holographic theory of mind. It's going to be part 18, Bergson and Tesla, where in disclaimer fashion, I'm going to say that I'm using Tesla here as a symbol for the ether theory. We'll be talking about Faraday, Maxwell, Heaviside, Tesla, Steinmetz, Alexanderson, and the mysterious demise of the great science and onslaught on electromagnetism, the quantum mechanics and special relativity takeover of physics in the field, notions of counter space, counter time inherent in the electromagnetic research and what was going on, and the very profound implications, remarkable implications that are hiding in this original concept. So why to Bergson? Well, the relation of subject and object in Bergson's theory is not in terms of space, but of time, which requires that the spatial field or space itself must be seen as a continuous field, whatever that field might mean, as extensity in Bergson's terms. To quote him, "And indeed we see force and matter drawing nearer together the more deeply the physicist has penetrated into their effects. We see force more and more materialized, the atom more and more idealized, the two terms converging towards a common limit, and the universe thus recovering its continuity from matter and memory." This subject-object relation is an essential piece in Bergson's concept of the brain as being a reconstructive wave passing through the holographic field. The universe is a holographic field specifying an image of the external world. That is, this subject-object relation removes the homunculus as the viewer of the image. Otherwise, we have the infinite regress of homunculus behind homunculus behind homunculus. But to relativist, particle physicist, to quantum mechanics, this is just pie in the sky. To them, their particles are very real. Their independent objects are very real. Rocks as independent objects, bottles, atoms, electrons, and our body is spatially separate from the field. They wouldn't buy the unity of subject and object in terms of space. Physics, with its classic metaphysic, which undergirds this entire notion of independent objects, of which the computer model of mind and AI is simply the logical expression, is the barrier to Bergson. Second thing, voluntary action. How we will to lift our finger, or to lift a weight, as Snoopy here. This is the relation of mind to matter. Now, the subject-object relation, as Bergson stated it, resolves this duality in favor of a continuum, a continuous field. This field has the attributes of mind. In its indivisible motion, it has a primary memory, or implies a primary memory. Its holographic aspects imply an elementary awareness defined throughout, just for starters. But this is but a base. We struggle yet to grasp, say, how does an image bring about motion and matter? i.e., how does a dream image of chasing a mouse bring about the motions in our little cat? Without a better understanding of this mind-matter field, how do we answer these questions? Again, physics, relativity, QM, and its metaphysic could care less of dealing with the question in these terms. They constitute the barrier. So what happened in physics? In 1996, when Bergson wrote Matter and Memory, the world was gripped by the revolution in electromagnetism that had been occurring and was poised for even greater discoveries. In all this, one concept permeated: the ether. The ether of Faraday, of Maxwell, of Heaviside, of Tesla, of Steinmetz, of J.J. Thomson, of Whittaker. These men were the creators of our current technology. The creators were not Einstein, or Bohr, or Schrödinger, or de Broglie. In Bergson's statement of the universe as a holographic field, namely, quote, the photograph already developed, already taken, already developed in the very heart of things and at all points of space, we see this as part of the derivation, pointing to Faraday. Bring in Faraday, centers of force. The lines of force emitted in every direction from every center bring to bear upon each the influence of the whole material world. In other words, invoking a form of holographic reflection of the whole. But by 1920, to pick a year, all progress in, all science in electromagnetism was dead. And we'll be seeing why shortly. It is a dead subject. Einstein, the relativist, quantum mechanics had replaced and halted it all. Einstein had declared the ether non-existent. Progress. So let me cast a doubt on what progress there's actually been since then. What has progress actually been since the establishment of the remarkable electrical foundation of our technological culture? What has been its nature? Well, ever faster computers, ever improving robots, and improvements on the horizon, ever better phones, iPhones, AI advancements, deep learning, neural nets, voice recognition, Siri, faster jets, a space program strangely halted. And then, of course, there's quantum mechanics, which appears to be promising remarkable progress. There's that quantum computer ever promised on the horizon. But, well, that's more computing. Note how much of progress has actually been advances in computing and computational technology, all simultaneously based on the same technological base that was established long ago. In those entanglement demonstrations where the QM folks show they can entangle two particles and make one instantly reflect the other's state, even though they're both vastly separated in distance. Well, allow me at this point to partially show you a card. The QM guys entangle, say, two photons, whatever photons actually are. Remember, they're just massless particles, whatever that means. This seems impressive. In 1902, a young Swede, Ernst Alexanderson, showed up at the General Electric labs. Charles Steinmetz, the head of the labs, hired him immediately. GE needed to get around the Tesla radio patents. Marconi was given great credit for the radio, all credit in actuality in current literature. A former Tesla assistant had simply stolen the concepts, then turned around and sued Tesla. And he ultimately lost. His radio system was, in fact, a far lesser system than Tesla's. Alexanderson went to work pursuing a different concept of the radio, where Tesla's system drilled a path through the ether from point A to point B without spreading out, without the energy spreading out. There were still connecting electrical lines of force. Alexanderson's system seems to be a kind of prelude to a situation where electricity will disappear in one location and reappear in another location without anything going on in between. That is, true action at a distance. This is what appears to be the case. Assume we have two devices based on Alexanderson's principles. If you have one antenna in San Francisco and one in LA, and everything is tuned properly, and if you were standing in the San Francisco device, you would be simultaneously standing in the device in LA, as long as the generators were running. This is not 2 photons, if you can see the difference. This is but one of the implications of the field of research that was just mysteriously ended. And I'll back up mysteriously soon. Ended in favor of the supposed advance of QM and Einstein's relativity. There's a bit of fishiness, as we'll discover. How did we get to Alexanderson? What is the physics of the ether? Well, let's see. Now, this assessment of Alexanderson's implications comes from Eric P. Dollard. Dollard, an electrical engineer, is a longtime student of Tesla and the ether theorist, Heaviside, Steinmetz, Alexanderson, J.J. Thompson. And as we'll see as you watch the comparative dates of all these people, they're clearly all Bergson's contemporaries, almost sometimes the exact years of birth and death. So Dollard is a unique being, a brilliant mind as far as I can see, with a unique background in history. That car there, for example, has been his home and office for many years. I'm compressing here his long discussion of the history of electricity and adding in some other YouTube discussions that are related that he's given. I'm following very closely his own words for the most part, except in my own unique presentation and presentation style, and of course quoting them often too. My purpose here, my goal, is to remove any concept that current physics should be considered a barrier, along with their classic metaphysic, to our understanding of Bergson and the subject-object relationship, but simultaneously to give us a view of just how far away, how on the wrong track physics might be in grasping our understanding, providing us an understanding of that matter field, of what I've called elsewhere in these YouTubes, the psychophysical field. So let's look at history, the history of electromagnetism as Dollard described it. Of course, I'm leaving things out and compressing to some degree. So we begin with Faraday. Faraday was experimenting with the voltaic battery from Volta. Place a metal in a sandwich with a liquid, say an electrolyte like salt, water, lemon juice, something basically corrosive. Now, all this electrical influence can be conveyed from one metal to the other and produce fire. Volta started compounding these cells, stacking them higher and higher, as over on the right there, creating more and more of this electrical condition. Eventually, he could produce a standing electrical flame. So Faraday was replicating this, happily creating sparks, when he noticed that a compass on the table would move every time he was drawing the sparks. That is, he found that magnetism was appearing, the compass being, of course, moved by magnetism, even though there were no magnets around. This was the beginning of electromagnetism, the foundation of all our current technology. So Faraday theorized if the compass is at one end of the table and the device that produces the inductance moving the magnet is at the other end, what is there in between? Take the demonstration standard with iron filings on a paper with a magnet beneath. The iron filings form a little fibrous structure. Faraday concluded that there was a fibrous structure in space that is responsible for action at a distance. Now, Newton had already concluded that gravity worked through empty space. The sun there pulling all the planets to it, working through empty space. Thus, we have action at a distance. And we know Newton himself was uncomfortable, felt physics was ungrounded until sense could be made of this. That is, you can affect an object at a distant point without anything, any kind of medium being in between. Faraday came up with the concept of the ether. The ether is a spatial medium. As Tesla would put it, an ultra-rarefied gas. There seems to be something prior to the elements, pre-hydrogen, this little atom, the primordial ether for Faraday. When the ether becomes polarized through some kind of hydrodynamical process, like tornadoes, twisters, vortices of water going down, these lines of force were appearing in this ether. Some force caused this to exist, a condition of imbalance in a normally static ether. So Faraday visualized the ether as static. And we're not going to go into this, but there's also conceptions of a dynamic ether. Post-Faraday, there was the development of the telegraph. This became a major onslaught in development. In 1866, for example, there was the first transatlantic cable. But performance was very slow, very poor on this cable. Transmission became very dicey. This will become part of the story quickly down the road. But this brings us to Maxwell, James Clerk Maxwell. At the time, most of the theoretical work was being done by Maxwell. He had a discovery that, as Dollard puts it, turned everyone's brain inside out. He was the first to learn what is termed the Newtonian Leibniz calculus, that is the infinitesimals. This introduced the dimension of time and the study thereof into natural phenomena. It was the most important thing that allowed electricity to be engineered ultimately, rather than just weird machines that shock people. It allowed us to look at how things change with time. Is it going faster? But how is it going fast? What is the rate at which something is going faster? This allowed the development of what is termed Faraday's law, that is, how much magnetism is appearing or disappearing with respect to time. So the way physicists were dealing with electricity was in terms of how much force it exerted on matter. They used scales like mass, like weighing our carrots. So much electromagnetic force pulls the scale a certain amount of distance. That's how all voltmeters worked after things were established. That is, how much force was delivered on something like a spring. That was the determination of the magnitude of an electrical quantity. Maxwell found that if you take a certain quantity of the magnetism and a certain quantity of the electricity that exist in space between the magnets and the coils and the whole thing, it always comes out to be the same numbers. Multiply them together, it always comes out to be 1 over c squared. That is 1 over the velocity of light squared. Maxwell hypothesized that this velocity of light must have something to do with what he was trying to discover, which was radio. He wanted to figure a way to communicate electricity from point A to point B to this primordial ether, and using the electrical lines of force. Maxwell theorized 2 types of propagation through space. One was electromagnetic, and this propagated at the velocity of light. The other was dielectric, and it became complicated to ascertain what type of velocity there would be. In fact, we shall see it's still not ascertained. Maxwell had to come up with a conjugate to Faraday's law, which could be called Maxwell's law, but it's never expressed this way in the history books, as Eric says. So Maxwell gave enough quantification to fields and forces that now physicists who could identify forces and were good at using scales and math had something to work with. Now, the telegraphers had made something, but they had no clue how it worked. The more they tried to build, the more it resisted them. And when it came to the undersea cable, they found that the telegraphic impulses would tumble head over heels down the line and become completely scattered out the other end. And the whole thing was a disaster. It took hours to transmit a message. The physicists came up with an explanation, diffusion theory. If I take an iron bar and take a torch and heat it up at one end, where it is now red hot, if I go down the bar, I find it's less and less hot. There's a curve to that. It's a very diffusion, a very characteristic mathematical curve as the heat drops off with distance, and it's always the same shape. So the physicists concluded that the electricity traveling down the cable in the form of a magnetic field acted in this manner. So they attempted to load the system to overcome this. And this was the wrong way to go. They needed to stop. And this brings us, as I failed to note, to Heaviside. Heaviside began engaging in experimental mathematics because the Maxwell stuff was basically impossible to use. For Eric, he doesn't think anyone to this day has fully comprehended Maxwell's work or even bothered to read it. It takes years, incredible labor, so it's just not happening. So Heaviside took Maxwell and started to experiment with it. He wanted to come up with a basic algebral expression that was easily solvable and didn't need all the incredible differential equations, partial derivatives, and things just too hard to deal with. For Dollard, it's just something that you can't apply to a working situation without turning your head inside out. Maxwell stuff, that is. So with regards to the cable, Heaviside theorized that the cable is propagating not a magnetic wave, but rather an electromagnetic wave. This wave has two parts, and these parts have to be kept in match. As the picture on the right showed, there's an electric field variation, there's a magnetic field variation at right angles to each. So Heaviside solved Maxwell's equation to come up with a famous equation in electrical engineering called the telegraphic equation. It takes 20 pages of Maxwell into one equation. And here it is. I'll explain the terms in a moment, but it has a real part and an imaginary part. The imaginary being because the minus 1, the square root of minus 1 there, minus 1 to the 1/2 on the right side, makes it imaginary. It's called the wave equation, and it's the fundamental equation from which all electromagnetism evolves. It's a second order differential. And most of these things are either per time squared or per time. And the RC over time is a famous constant called the RC time constant. What Heaviside found for the situation of the cable is basically you have the two basic waves, the magnetic, the L, and the dielectric, the C in the equation. And then you have the rate at which the wire eats things up, R, and the rate at which the insulation eats things up, namely G. The problem was the wire eats things up faster than the insulation eats things up. When the magnetic wave is propagating down the line, it's getting eaten up faster than the dielectric portion propagating down the line. Heaviside, seeing that the magnetism was being weakened, used iron wire or magnetic tape along the cable at specific distances to raise the magnetism to where it should have been. So he kept reinforcing the magnetism down the cable. Now the two dissipations were equal, and all the signals came perfectly clear out the other end of the line. This was simply unacceptable to the Royal Society in London. They hounded him right down to the grave. He would not die quickly. He wrote a giant, I think it's 1,800 pages, 3-volume book on the subject, and came up with almost every electrical equation and term we use today. Maxwell's equations in every basic book in engineering are, per Eric Dollard, Heaviside's equations. They have nothing to do with Maxwell. He was the one that developed the symbolic math of the curl, the div, and other stuff. He said, I got the baggage off of Maxwell. I might note there's a semi-conspiracy theory out there that says that Heaviside got rid of certain things in Maxwell called quaternions that Hamilton had developed that thereby sort of obscured the role of the ether. But I think when we look at the totality of what Heaviside is trying to do, this is a questionable conspiracy theory. But electrical engineering from that point on was made possible because you had these nice, simple algebraic things to deal with. Now, he did not like teaching people. The more complicated he could make it, the happier he was. His books have little stories and parables. They're not your normal engineering books. And he was a first-rate oddity, always ready to eat out of garbage cans. As Eric says, part of the reason why he died was because the neighbor kids always threw stones at him so much he could not leave his house. But this takes us to Edison. Meanwhile, while this is happening, Edison was working to put an electric lighting system in New York. He'd already invented his electric light. The gas companies were not happy. They forced Edison to put all the wiring underground, but there was no such technology. There was only telegraph stuff. But Edison needed a 2-gauge copper cable, a small cable, not an 8-gauge monster. So what he did is use iron pipes filled with tar with a copper pipe in the middle. It became known as the Edison tube. So he built this network of piping and a generator station at Pearl Street. Never ever done before. He was on his own. There was no physics, no volt, no amp, no farad. There was no handbook for resistance tables off the wire. So he closed the switch, tried to hook all the generators in parallel, and it blasted. But in several hours, he got it going. Everything lit up, and we had history. I'm noting Edison here because we just need him a bit for context for Tesla. So now he starts creating motors. The famous Edison motor is 2 very long solenoidal coils that stand 8 feet high and a rotor at the bottom. Basically, he had just amped up the telegraph magnet, but that's all there was to work with at the time. So enter Tesla. Tesla came to the US in 1884. He almost doesn't get in because he has no money. He has a letter from the Edison Electric Company in France. Edison lets him in. Tesla describes his discovery. Edison is not interested. Edison wants Tesla to work on motors. Tesla, who's already gaining a knowledge of how these rotating fields are supposed to work, points out that these huge coils are foolish, that they should be wrapped inside the motor. Edison said, well, if you can develop that, I'll give you $25,000. So Tesla went right to work. And shortly, he developed the present-day DC motor, direct current motor, which is basically a square block instead of a tall column. It was a great success, and Tesla didn't get a dime from Edison. So Tesla left and was digging ditches on the street. Some Western Union folks got him to work with them, and he worked his way up and up with the Western Union organization. He decided he would come up with a motor that didn't need all this sparking and rigging and all the real fine wires on the coils and all the complications, which we'll get to. he would eliminate all this and come up with the perfect magnetic whirlwind. The rotor would spin in the ether with no contact whatsoever by setting up a magnetic vortex. But there was no way to conceive such a thing at the time because basically everything in electricity was positive and negative, a positive-negative reality. So you couldn't make anything spin, just go back and forth because of the positive and negative. They thought and thought, but there was no way. You had to have the commutator as the carrot in front of the horse to trick the field. What's the commutator? Well, a little diagram to the left there, we have a very basic little direct current electric motor. It's running from a battery there. The battery from the positive terminal sends the current, and right there on the we see the two golden and yellow discs. It's actually a piece of a ring that formed the commutator. And of course the current's going through the loop and coming back. Okay. Now there's a little rule called the left-hand rule on the top there for the left, or the motor rule. There's also a right-hand rule, but this is a left-hand rule for motors. And given the initial direction of the current, in the initial direction there, the motion of the left side of the wire loop will be up, because the magnetic field, once the current starts flowing in the magnetic field, the motion, according to the right or left-hand rule there, will be up. But now, in your mind, you have to watch that wire loop then start to rotate, move up because of the field. But note the gap in the commutator. As the wire turns, it's going to be forced to cross the gap. Okay, the ends will cross the gap, and then the wire end, which is originally on the left, receiving the negative side, is now on the other side receiving the positive current. So now the other side is moved up, and the field is essentially tricked. The loop constantly circles. So the motor is fooled into spinning. But if we ramp up this little motor with a whole lot more coils, etc., as in the right there, there's a real DC motor. What we find out is the thing throws off dust and sparks and is problematic with maintenance and horribly inefficient because they have to have these big magnet coils with lots of current flowing through them. So how to defeat this? How do you defeat the inevitable reversal of the motion of our wire loop there due to the magnetic field given the current's direction? It seemed undefeatable. Tesla thought the problem in his head. Everyone told him it was impossible. Physics thought it was impossible. So while we were reciting a poem about the sun going down and simultaneously coming up somewhere else, he got the idea of the quadrupolar polarity. That is, you have two pluses and two minuses at right angles to each other, and you switch them. What Tesla did is create a way to make alternating current carry around, just like the phases of the moon. He drew it out in the sand. The whole developed right there in his mind. And Tesla, we should know, was renowned for running motors in his head and returning months later mentally to check out the wear and tear. Tesla was quite an advanced being. Edison was very upset. No one wanted Tesla's AC motor. But then Tesla met George Westinghouse, who made things for trains, namely brakes, and the magnetic things, and he suddenly had an ally. Edison, in turn, turned to his old enemies, the gas companies, in opposition to Tesla. And he started getting reject circus animals, as well as dogs and cats, and had them, quote-unquote, Westinghoused on stage. 2,000 to 3,000 volts of alternating current. In one case, an elephant named Topsy, he had electrocuted crumbled to the ground with smoke shooting out. Probably took 50 to 75 kilowatts, as Dollard thought. The electric chair takes 5 kilowatts, so poor Topsy. Tesla was getting rocks through the window, but Tesla aced out Edison. He had discovered by this time a completely new type of electricity. It was neither DC nor AC. It's called impulse electricity. Impulse electricity behaves in an extraordinary way, getting back to the ether concept, because what it would produce was so bizarre. It almost looked like the aurora borealis around his coils. He found that rather than damage the body actually seems to benefit. Tesla was to give a demo of his recent discoveries. The presentation was given in Europe, using devices based on this impulse electricity. It was spectacular. It was so fantastic, he became a worldwide hit, not only as a scientist, but as a magician. What he'd accomplished, which for Dollard no one has been able to duplicate to this day, is connecting himself to these devices, closing the switch, and lighting himself up like a neon bulb on stage without a burn or a mark on his clothes. Then he pronounced, "Here are the dangers of alternating current," and he laughed. That ended Edison and the direct current, alternating current controversy right there. Tesla kept pursuing this technology. What he found kind of defeated physics and the electrical engineering world. That's basically why there is no knowledge or information on it. It is just blocked off, kind of impossible. But for Dollard, if you build according to what Tesla says, where he did in fact describe things, you can duplicate everything if you follow the instructions. With his high-frequency experimenting and his mechanical analogs to go along with it, he had created a way to defeat the Newtonian action-reaction law, where every force has a counterforce. Basically, you had a push without having to lean against anything. He did it both mechanically and electrically. What he found is that similar devices that operate in the same frequencies or rates would communicate energy between each other. So this is basically radio, with the difference that there is no real energy loss between devices. You can transmit from one to the other, and it's like there's nothing going on in between. There's nothing measurable between. His aim was to build a worldwide power system based on this principle, and it would be tuned to the natural resonant frequency of the Earth. You disconnect all the generating systems for the solar system would be run the electrical plant with one electrical system, with the electrical system of the Earth. His experiment in Colorado, 1899 to 1900, was to prove that he could use the Earth for this. He figured out the frequency of the Earth, or the harmonic, that he could use. He started with 80 and worked down to about 50 kilocycles. A coil 50 feet in diameter, the output terminal on at least a 100-foot mast. He would send an impulse into the Earth that would bounce off and come back at a certain time with an increase or decrease of energy. And he would continue this impulse at his 50 kilocycle rate until he would produce a giant fountain of electrical activity in the Earth. Colorado was a safe place to do this. He closed the switch after all the tests and produced for 1 minute a standing lightning bolt at the terminal, modulated at about 5K cycles per second from his capacitor discharge switch. The sound must have been fantastic. He had succeeded in concentrating the entire electrical activity of the Earth into his station in Colorado. What Tesla did in using these impulse currents and oscillating currents in his engineering had come up with another type of polarity where there is only one pole. If you're going to transmit electricity over the ground and you put 2 ground rods in the Earth and connect these to a battery, DC battery, as the telegraphers found out, most electricity just goes between the ground rods. If you use AC or quadrupole and have 4 ground rods, and all it's going to do is spin around inside these rods. Tesla came up with an electrical device where he could connect it to something like this Earth, and it would create an electrical movement in the Earth, but it wouldn't have anything else to connect to. It was one pole, simply a plus. There was no negative. There was no return circuit. Here's where Tesla's work is most important. The implication is the existence of another space, counter space. We'll get there in a second. He moved back to New York, where he began to build his final station, Wardenclyffe. This was not an experiment, but something that worked, so he could start applying it to electrical transmission. This was around 1903, and he was promptly put out of business. His backer, J.P. Morgan, withdrew all his funds. He spent the rest of his time as a homeless person feeding pigeons on the street, basically the entirety of his adult life. Now, Tesla built all this stuff in his head. He left no engineering math. He didn't need it. So no one could duplicate his devices. You didn't know how much iron to use, how much copper. People would try to duplicate. It just kept burning up. Steinmetz took the Heaviside mathematics and developed it into an extremely powerful engineering tool. He was doing things in the laboratory that are beyond conception for Dollard. He even has a reputation for building a time camera. In 1900, he wrote a book, The Theory and Calculation of Alternating Current Phenomena. This made him famous. He found out why the AC motors were heating up and burning up. What Steinmetz found is that when you have current applied to electrical systems and force magnetism into existence, the rate at which magnetism develops is not the same as the rate at which it dissipates. The force and force field do not tie together anymore. They don't happen at the same time. What this does is cause a massive loss of energy. So he had to figure a way to work with only magnetic materials that didn't have this what's called hysteresis effect, and laminate the iron instead of using blocks so that the magnetism would not be shoved into the iron but instead be guided by it. And lo, the AC motor was now entirely engineerable without Tesla and without Westinghouse. And AC flourished at that point. The book he wrote is almost like an acid trip. For Dollard, I read all the standard texts, Maxwell Faraday textbooks. None could give me what I needed for my work at RCA. They were either useless or too much work to get anywhere. Steinmetz had turned all this into little high school algebra equations. He used what he calls symbolic algebra, extremely important, for it allows for conceiving things that are not in our normal dimensional reality. Another problem that goes along with this simultaneously that he had to work on. In the DC context, when you open the switch, you can't turn the electricity off. It will blast. Steinmetz had stopped things from cooking. He had to stop the exploding. Magnetism and dielectric fields have stored energy. If it has nowhere to go, it will blast a hole to get there. When you turn it off, the current has to change at some rate. It has to move. It has to go in another direction. The whole electrical system has to readjust. Usually this starts in oscillation, where the energy in readjusting bounces between forms. This bouncing between forms is the hysteresis effect, where the sine wave is compounded with the dampening wave, and this produces oscillating current. So you get transient currents or impulse currents. The dampening curves always move in an exponential form. And it turns out to be the same exponents as associated with things cooling off or leaking or any kind of dissipative phenomena. It always occurs like gravity as a rate upon a rate. It's also a frequency of a type, but an imaginary frequency, and it's not in cycles per second, but in decibels per second. A generalized electric transmit, say along our wire lines up there, will be some combination of these. And these things are running up and down the transmission lines and getting in the transformer coils, and sparks and fires and sparks jumping off the lines, hitting people for no apparent reason, and as Dollar says, blasting them out of existence. So Steinmetz wrote his second book, The Theory and Calculation of Transient Electrical Phenomena and Oscillations. This book held an understanding of electricity that is so far in advance of anything today. For Dollard, it's mind-boggling. And this is what Alexanderson had to work with in developing his radio, as we'll soon see. So the book had such an impact on the electrical engineering community that a young guy, Ernst Alexanderson, came over from Sweden, as we noted, in 1902, where he had been studying electrical engineering. He got on the first boat, came over to New York, and stood in front of Steinmetz. Steinmetz, apparently with the intuition of great minds to great minds, took him right in. They developed a type of radio, like the Tesla system, but another type. Having all Steinmetz's knowledge and abilities and GE labs at his disposal, the whole idea was to get around the Tesla patents. You could not develop radio unless you got around the Tesla patents. Marconi, who worked for Tesla and stole his plans, simply sued. Marconi created something that resembled Tesla systems, as we noted, but it wasn't, and he ultimately lost the lawsuit. But Alexanderson had to get around both Tesla and Marconi. But based on the Marconi system, he developed another type. What Alexanderson had done, he had figured out a way to make an electric structure that is termed scalar. That is, there is no variation in space. There is no wave, no direction in space. You may have heard of scalar waves. This is a complete contradiction in terms. There is no such thing as a scalar wave. There's only scalars. At atmospheric pressure over a region, given this the same altitude, would be a scalar. A barometer will read, say, 29.9 everywhere in this region. It's a scalar quantity. If you have the structure and the switch is closed, things turned on, and there's 100,000 volts at one end of the antenna at t equals 0, at the other antenna at t equals 0, there's 100,000 volts. That is, there's no time delay for the wave to get from one end to the other. Velocity is completely neutralized. That is, there is no velocity. There's no vector traveling from A to B. The first place this was done was in a place called Bolinas, California. This is the first full implementation of Alexanderson's system. The velocity in Alexander's system is engineerable. It has no relation to the velocity of light, other than infinite velocity, and the velocity of light are like two poles or zeros in the system, like nodal points where it crosses from one state to the other.
Marconi's version of Tesla's system was a bastardization. Impedance mismatched, it would work with a lot of juice. They built 5 stations, Hawaii, Bolinas, California, 3 others, but it's 1913, 1914, and it's World War I. Marconi was a foreigner. The Navy wanted him out. So they used the Alexanderson system, scalar, no velocity, and formed RCA to take over these stations. FDR, Roosevelt, then Assistant Secretary of the Navy, decided to go even further and had made it illegal to own a radio in 1919. So again, we get something very fishy. It seems that the capabilities of these systems must have been understood and feared to go so far in, shall we say, their prohibition. Per Dollard, this is the signal year for the death of electrical engineering. When RCA was formed, they formed a patent pool. No one could build tubes, capacitors, anything, unless RCA decided it was to their behalf. And RCA, we should note, is now defunct. So, as Eric notes in his discussion, procuring these types of components, vacuum tubes, capacitors, etc., that are needed for this kind of, shall we say, far-out research is now virtually impossible. These components are very rare. They're no longer being made. And in actuality, then we're seeing, at least in the public domain, the complete end of this type of experimentation and research. I would say if you want to see just a little bit of the pathos here, look at Eric's presentation at 2 hours and 16 minutes, where he's talking about Philo Farnsworth III, the son of the inventor of TV, and you'll get it in about 10 minutes to 226. There's quite a vision of just what could be. So the reason we want to get to these guys and why we went through the history so we get an appreciation of it is that Tesla found a way to get out of space into another dimension. And Alexanderson found a way to circumvent space completely and make things appear at another place without any time delay in between. If we want to talk to Alpha Centauri, we would not use waves that propagate at the velocity of light. That would be slow and dumb. If we use Tesla's way, we would need a medium that could handle the flux density and the transmission of power, and that would not be likely between here and Alpha Centauri. So the best thing to do is build electrical devices that respond in a scalar manner in regards to space. In other words, Alexanderson's way. Then you would not have to wait for the signal to get there. Let me note a point here that we'll need as we go. I'm noting scalar, longitudinal, transverse waves. Now, scalar, I'm not saying waves because they're not waves. There's no direction, there's no vector, there's simply a quantity. But Maxwell considered two types of waves. The first is transverse, like waves on the surface of the ocean. Now, first thing, there has to be a boundary. The water has a surface, for example, that's the boundary. And the motion of the waves is up and down. The motion of the water, the matter, whatever, is always at right angles to the direction that the wave is moving. Now, it's slow. It is the energy. It tends to circulate in one area and then move on to the next and then to the next. The energy is always sideways or perpendicular to where the wave is going. It's transverse. Longitudinal wave, an example, so if I set off a load of dynamite underneath the water, it's like a shock wave. Another place in the water feels the shock instantly without any delay at all. Or I take an iron beam and hit it on the end with a hammer, whack it. You can't see that wave, but it's instantly at the other end. It's a longitudinal wave. The material or energy is going in the same direction that the propagation is moving. So physics, of course, holds that electromagnetism is a transverse wave. The first complication that comes to mind is, where is the boundary? If that's my universe up there, my block of jello, where is the actual boundary of the universe? We're seeing a bit of a transverse wave run across the top surface of the jello, but when that bullet hits, that's a longitudinal wave that whips instantly, and the other end of the jello feels that instantaneously. But we have no such boundary in our jello universe there. There is none. And thus Tesla said there are no transverse waves. They have to be longitudinal. And of course, via longitudinal waves is exactly how Alexanderson's station worked. So this is a problem for physics.
It is per Dollard a misunderstanding of Maxwell, but it'll get worse as we go. So if we step back and look at electromagnetism in general here, we have this simple relationship E equals phi over T, where electrodynamics was created from this simple relationship. If I have a quantity of magnetism, call it phi, and I vary it with respect to time, T, something appears. An electromagnetic force, electromotive force, E. Now there's a pair of equations in electricity because electricity is working in two dimensions. There is magnetism and there is the dielectric field. There's two quantities. If I take the Greek letter psi to represent the dielectric or the electrostatic field and vary that with respect to time and give the rate change the letter I get psi over T equal I, or the magnetic or the dielectric field varying over time is the rate of change of the current. So we have this two-dimensional relationship. We have the electromotive force E and the current I. So if I take a quantity of electricity, which I represent by the lowercase phi, it must consist of an electric field and a magnetic field. The magnetism phi exists in space, and the dielectric field psi exists in counter space. If I take this quantity phi, it represents the ether in its electrified state. Phi has dimensions of time, of magnetism, and it turns out that the dimensions of phi can only exist in Planck quantities, that is, only in integral multiples. So yes, what we have is the Planck constant, which is the very foundation of quantum mechanics. But this is equally justification for the lines of force theory. For the lines of force have definite size and some dimension. And electricity then can only exist in steps in these dimensions, since electricity is only made out of lines of force. We can't have 1.37 units of electrical induction because it has to be a whole number in steps. So we just make Planck's constant 1 in our equation. That's what Steinmetz did to make his 20-page equations into little algebraic relationships. He just began using light seconds instead of normal lengths and times, and everything drops to 1. You didn't have to be stuck in both dimensions, space and time, to do your calculations. That's the only way you could convert the waves that were bouncing up and down the transmission lines, where there seemed to be no way you could calculate them because they were in another dimension. They were all trapped in these time dimensions or space dimensions, counter space, counter time, and appear not to be there. So electricity has always been a four-pole situation, existing never less than two dimensions at one time. There is no electricity unless you have magnetism, phi, and dielectricity, that is psi. Steinmetz had created an algebra of operators. For example, do the subtraction 1 minus 1 equals 0. We don't actually subtract, we use an operator, minus 1 times 1, then add the 1 to get 0. So electricity gives us the case where we have to have 1 multiplied by plus 1, and where we have minus 1 multiplied by plus 1. So we have our positives and negatives, but now we have this counter space situation. So how to express that? Well, we take 1 to the plus 1 power, and we have its conjugate, 1 to the minus 1, or its denial, as we'll see. So now we have taken a step from addition and subtraction to having multiplication and division. So this is a compounding process. It's always in log form. It's not additive. It's cumulative, building in a certain sense, like 1, 4, 8, 16, 32, etc. so what electricity implies. Addition and subtraction via our operator, is our time field. But the 1 to the plus 1, 1 to the minus 1, the exponentiation, is the spatial field. You have electricity that goes forwards in time and that goes backwards in time, or in time and counter time. You have electricity that exists in space, our normal space as we understand space, and that exists in counter space. This algebra of Steinmetz leads to 8 poles of energy exchange. As we can see on the right in Eric's picture, the vertical dimension with 2 poles, plus 1 and minus 1. There's a horizontal dimension, minus j, plus j being the poles, and these 2 dimensions and their 4 poles are required for Tesla's AC current. The 2 diagonal dimensions with their poles required to describe other forms of current, of which there are 8 forms of electrical waves, DC being the top left, AC being a straight line top left, AC on the right, sinusoidal current, sinusoidal wave. There's impulse currents, various forms, and we'll consider this a little bit as we go. And one can see this algebra extended in this U-tube of Eric energy synthesis, roughly at point 2.06, where this algebra is extended to these waves, and we see how this algebra works quite simply but very remarkably. It's quite revealing. In any case, the implication of all this hides, so to speak, right above our heads. Those power lines. So these 2 things, phi and psi, have what's called in electromagnetism a conjugate relationship, in that one is the denial of the other. And that's how one can be calculated from the other, and that's what gives Maxwell's velocity of light situation. So let's start with electromagnetism, because that's what everyone knows about. When I look down the street and see these 2 black wires on the poles, the wires are actually trapping the electricity, so it can go only up and down the line. But there's no electricity flowing in the lines whatsoever. It's in the space between the wires. Yes, we can measure amps at each point along a wire, but this does not mean the current is flowing in the sense normally understood. So if we take these wires and take a cross-section, what we find around these wires are circulations of ether. One in one direction, one in the other. We have a kind of plus and minus transmission situation. This is called magnetism. And everyone's held magnets and felt the force between. So what this does is create a concentration of magnetism between the wires that predominantly moves vertically at right angles to the power flow. This magnetism physically pushes the wires apart. If we were talking bus lines, for example, when the buses were running, the wires are further apart than when the buses have stopped. So there's definitely some kind of pressure existing between the wires. If I take a 150-foot section of the line, there's a quantity of magnetism in between the cables of the 150-foot section due to this circulatory ether condition pushing the cables apart. If I have the cables move apart, spreading them apart more, say by putting in another insulator, now the space between will hold more magnetism. If I put a chunk of iron or some kind of magnetic material in between those wires, the iron will suck in the magnetism, and again there will be more magnetic storage capability inside the magnetic structure. If I keep increasing the current, the magnetism, so that the iron can't hold anymore, the iron goes into what's called saturation, and it will no longer hold any magnetism. And all the rest of the magnetism that is produced will have to continue to exist outside the iron. All of these things are completely typical of space. You can only jam so much in the bottle.
Let's look at the wires further. Not only are we dealing with a current of 2500 amps, for example, where we're dealing, say, with a bus line, but with a voltage of 600 volts. You have the volts and the amps, the magnetic and the dielectric, before you have electricity. The magnetic and the dielectric are prior. With respect to these lines of force, if I focus it on a wire, or two wires here, as I have in the red, the dielectric is completely contrary. It's conjugate to the magnetic. It will always be at 90 degrees, and no alteration of this is possible. If one field is one way, the other is the other way. Where the magnetic field forms closed loops circling around the wire in a circulatory type of fashion, the dielectric, these being lines that contact that metal surfaces, is radialized. So the dielectric lines come out and they arch, each point of the arch being at right angles to whatever magnetism exists. So now we have another field of force, conjugate, and the two make up the electric field. A little better picture of these lines of force. Again, we see the magnetic lines of force circling the wire, the phi field, and the dielectric lines of force coming out of the wires and arching at right angles to the magnetic lines, or the psi field. So the magnetic lines are motions or velocities. The dielectric lines are torque or compressions or tension. This tension in the dielectric is termed voltage or potential difference. The magnetic lines of force exist in outer space or normal space, the space that exists outside us, reaching before us on the table, stretching our normal space. But the dielectric lines of force exist in inner space, or what I've already called counter space. So a capacitance, that is the storage of the dielectric force, we have a paradox, because the smaller the boundary area, the more the energy is stored. Boundary area being, for example, the two wires on our transmission lines. So the smaller this area, the more the energy is stored. Why? Because the energy exists in counter space. So the electric field between transmission lines represents the storage of energy in two different dimensions of space. Now, the more I raise the voltage, which is, say, focusing on the electrostatic side of things, the more it wants to pull the wires together, as opposed to the magnetic side that was pushing them apart. Again, we have the conjugate, the denial. If I move the wires closer together, the electrostatic lines of force become even more concentrated. So if I move them closer together, the more electrostatic energy the system will store. It will tend to pull them together. So now we start to get into the concept of counter space. We've entered the counter space logic at this point. We have two spatial conditions, magnetic and dielectric. If we put a piece of glass between the wires, as I did the iron bar, it will absorb more dielectric lines of force, and the energy storage will be greater. If I keep turning up the voltage, again, dielectric side, to the point where the glass starts to saturate and can't handle anymore, what happens is that instead of pushing the lines of force out, the glass will start to draw even more lines of force in, to the point which it blasts. And that's when you get sparks across the power lines, lightning discharges, etc. So let's take lightning discharge as another flux example. So we have the cloud, the Earth, and now we have the space that's filled with a quantity of electrostatic lines of force, which are basically trying to pull the cloud and the Earth together, the pulling. What happens? The cloud evaporates. The water, holding 50x, at least 50 times at least, the amount of electrostatic that the air can hold, is releasing this electricity, and it has nowhere to go. So what happens? These lines of force between the cloud and the Earth become tighter and tighter. And just like the point of saturation in the piece of glass we just talked about, as I kept turning the voltage up, and it started to spark inside and then blasted, the atoms
start to break apart at the point of saturation, and you get a breakdown zone. And all the lines of force come rushing towards that zone and discharge the complete cubic volume of force in the electrostatic in one column of flame. The saturation is complete and total. There's nothing jumping from cloud to cloud. These are all stories, myths. If you build your lightning system on these myths, as Eric loves to say, then you're more than sure to get, like he says, blasted. It's a saturation. It's moving sideways. As such, that whole electrostatic field of force is moving sideways to that break point. If I have a bottle of water and the water represents an electrostatic field, then suddenly the water has something break down in the middle, again a break line, and more water rushes in. It's like the whole jar of water collapses in upon itself into nothing. The energy density is so high at that point that the fire appears, and that's why there's the blast. So lightning is not moving vertically, it's a saturation collapse coming in horizontally, and this is what's called impulse current. It's a saturation into counter space. So looking at the wire cross-section, where one of these lines of electrostatic force and one of the magnetic force lines cross, a little circle there, you have a multiplication, or an X. X, or the cross, the symbol of multiplication, takes us back to that polarity, always the four-pointed cross. This is an old Indian archetype. India. At the conjunction point, in space and counter space, is produced the electromagnetism that moves down the line and is represented by Planck's constant. This is the product of the electrostatic and magnetic lines of force, and this is what exists in quantum steps. And this is what propagates at the velocity of light. What rate the magnetic lines of force and the dielectric lines of force move has never been determined. The equations exist in Steinmetz books, as Dollard points out, to make the determination, but no one has ever done the experiments. But they necessarily have to be doing something because the energy is moving. The movement of the lines of force along the wire, they're essentially scraping, so to speak, into the wire, because the wire is not a perfect conductor. The wire, however, is not conducting electricity. It's the ether that it's conducting. The wire is a reflector. That is why the electromagnetic boundaries use a material that reflects light for the so-called conductors, and the material that absorbs light for the so-called insulators. All the electromagnetic boundaries must be capable of reflection, or they will not work. So we have electricity essentially trapped between two mirrors. But electricity is of such a dimensional nature that it doesn't have to be complete. The trapping doesn't have to be complete. You don't need mirrors on all sides, 360 degrees. Just the presence of the cables such that nothing can get through them. The electrostatic lines are such that they have to embed themselves in the wire. They have to make contact with electrons and protons, which are the ends of the electrostatic lines of force. In themselves, the electrons and protons have no material physical existence. They are the terminals of this type of electrostatic condition. And this is where, as Dollard notes, the theory of relativity collapses. So the speed of light, commotion traveling down the line, is dragging through the wire. The wire basically burns up the electricity. There's a sympathetic current flow in the wire which cannot move anywhere near the velocity of light down the line. It's a situation quite analogous to where you're going down the road in your car and you've got to slam on the brakes. As you skid down the road, it makes a sound which is called inharmonic. It's a distortion type of sound where energy is being destroyed or consumed. Part of the road will be carried along with the car, but not at the same rate as the car. Pieces of the road will be left behind. This is why the wires get hot and give the indication of current flow. But the current flow is the rate at which the electricity is destroyed. The triple wire configuration that we see is curious. It happens to use the least amount of metal to carry electricity from A to B. For four-phase electricity, you'd use 4 wires. For two-phase, 2 wires. But for some reason, this three-phase takes the least amount of mass, your transformers and transmission lines, but no one has ever been able to explain it. The mass quantity in the electrical system has a low in that, if you draw a low point in a U-curve. And it'd be interesting to see that analyzed, as Dollard says. 3 wires will transmit the most electricity of any electromagnetic boundary phase type situation. Not 6 or 4 or 2, but 3. These electrical pioneers got it to the point where it was mathematically there to work with, and then it all stopped. Basically, what needs to be done is go back and pick up where these guys left off. So if you look up at a telephone pole, there's always a multiple of conductors, typically 3, to establish the boundary that confines the electromagnetic wave. But the problem with 3 wires and 3 phases, electricity is basically a 4-pole phenomenon. So now when you try to make it 3 poles going down the line, not only do you have the transverse wave, where we discuss transverse waves, and what I think here Eric means is that this is a misconception or a theoretical wave in the first place, but also the fact that there is no plus and minus, but that it's partially in between. It's a triangle now instead of a cross. You have a longitudinal current going sideways between the wires, so the power flow down the 3-phase is no longer electromagnetic, but is a complex electric spiral. Steinmetz tried to crack this, but he backed down from it because it was just a little too far to go for what was going on at the time. So when you look at the power lines, it's far from just metal, and we should now have an idea of the actual dynamic involved up there. But what the relativists did was basically say, there is no electric field. It doesn't exist. There's no dielectric. All you have is the crossing point, X, of these 2 fields, which they call the photon, or a photon. And none of this stuff, for example, the dielectric lines of force, even exist. It's simply not there. Yet the theory of relativity emerged from the writings of J.J. Thomson and a few others, Thompson being the most important. As we saw in 8a, he was already deriving the increase of mass via velocity. Now J.J. revitalized the Faraday theory when the rest of the world was regressing, as Eric likes to say, into the Newtonian action at a distance theory, that is, gravity being an actual force that acts without any medium. To him, the lines of force were real. They were solid. They were there. It was Thomson that discovered the electron. In J.J.'s model, take 2 metal plates in a vacuum with 1,000 volts inside, an intense dielectric field. It's straining everything. The plates are being pulled together. It's one of those electrostatic saturation conditions. If I keep cranking up the voltage, the field starts to pull what it's connected to, and the atom's out. The atom can't hold it anymore. It's starting to yank out. So one line of force will break loose, and you have what's called an electron at that end of the line, because the line of force cannot just break and end in space, according to the Faraday theory. You have a rubber band of a line of force that's snapping, so to speak, back and forth. And the energy is being discharged and is snapping to the other plate, the positive plate. And that produces a physical action and a heat. For Einstein, there are no lines of force. All we have is an electron, which is like a ball bearing, as Eric likes to call it, an empty space. And if we drop it or several to the floor, we have electrons rolling all over the floor. But it just doesn't work out that way. The electron seems to have no real mass. The mass is all to do with how the electric field is moving, and has nothing to do with the physical object, the so-called electron. Further, you cannot make it faster. If you have all the energy in the world, you can make it move at the velocity of light. Anything less than that amount of energy, the electron cannot reach that speed. So Dollard notes that this increase of mass is the basis for the proof, however, of the theory of relativity, to which I would probably note, no, not really. First of all, the relationship of mass to energy and speed of light does not rely on relativity. Thomson already derived it. I noted that mostly in 8a, slide number 70. And secondly, the increase in mass actually destroys the consistent version of STR. For example, if I have a rocket observer going by another observer in a flying saucer, just stationary, supposedly in space, and the rocket observer proceeds on, and due to his vastly increased mass, he's moving to the speed of light, he destroys a nearby planet. It's very hard now to invoke reciprocity. And for the rocket observer to say, no, I was at rest, and you, Mr. Flying Saucer person, were in motion, as relativity would demand consistently, because the destroyed planet clearly is evidence to the contrary, stands in the way. In other words, the mass increase of relativity is an ontological effect, and in no way ever can become a measurement effect as a consistent usage and interpretation of the original special relativity demands. So this in itself should be the final nail proof and end of the relativity and consignment to the coffin. However, in this strange world where, as we've seen, an entire impressive science can be disappeared, I guess what can we expect? The electron is not a ball bearing. The implication of J.J. Thomson's work, space is filled with electricity. We don't know what the voltage of the planet is with respect to the sun. We just can't say what the magnetic field intensity is. But at any rate, if I have my car sitting out in the street, well, it's metal. It has lines of force attached to it, grounding it to the earth. And according to Thompson, that's the reason why when I slam on the brakes, the car doesn't come to an instantaneous stop. The electricity has to discharge. So JJ's concept, if I make the voltage and the current associated with the metallic body of the car equal to the potential of that place where you stood in the universe, so that all the lines of force detach, so there's no difference in polarity, you could step on the brakes and the car would come to an instantaneous halt. Basically, velocities and all those things would lose their meanings because there would be no restriction to the movement. Now that sounds good, but the problem is, how do we begin? The Einsteiners, as Eric likes to call them, tell us there's no universal ground or point of rest. Since everything is relative, there's no point that's at rest in space. So we'd have to wave the surrender flag at once and give up. But if someone said, as Eric likes to say, pointing a gun at your head, nope, you're going to figure it out. Well, Tesla came up with this unipolar concept that we referenced earlier, where he could ground into counter space. This was in the context of his impulse currents. So a Tesla device could be phased or tuned in such a way that if counter space were neutral, it would be as a universal grounding point. And grounded against that, then your vehicle would have no potential because it would be grounded in this dimension of counter space, and all the electrical lines of force would disappear. And speaking of disappearing, Thompson, we should note, essentially disappeared himself. In the face of the onslaught of relativity and quantum mechanics, he pretty much gave up and bowed out of the picture. So some conclusions, very short ones. Special relativity, it is quite clear, given everything covered in parts 8a and part 8b, as we saw, has zero value. In its current interpretation, as physics gives it to us, it's a logical mess. Its actually consistent interpretation is pretty much useless as an explanation for anything. Quantum mechanics, the implicit critique being leveled here should give everyone pause, for it would seem QM is dealing only with a special case of a far greater reality, that is the ether and its two dimensions, dielectric and magnetic, and being perhaps purposely ignored, at least ignored. The ether also implies simultaneous causal flows, simultaneity, again as we discussed in part 8b, and the motions of objects as changes or transfers of state in the global motion of this whole also implied. It is beyond extremely doubtful that the ether was destroyed by QM and Einstein. Technically, Einstein destroyed it, so to speak, with a double blow of his special relativity and his explanation of the photoelectric effect. It's also extremely doubtful that the ether does not exist, given the doubtful destruction. Physics and this metaphysic, the classic metaphysic, in no way then can be taken as a barrier to Bergson's vision, the relation or differentiation of subject and object, not in terms of space, but in terms of time, with all this implies. And with respect to voluntary action, to tie up one more string, or as I like to view it, how images bring about action in the body, given what we have seen in this presentation, that is how far physics could well be from embracing any real understanding of the matter field, or what I like to term the psychophysical field. And given QM, where we've seen versions of QM such as Kramer, such as Bohm, and of course there are innumerable other versions, it's hard to imagine QM being ever remotely close, nor anything one might see on a breakthrough site, such as FQXI, where we're encouraging breakthroughs in physics from the current stasis, until physics gets on the right path in understanding this psychophysical field and the ether. Furthering Bergson in this regard will be possible, but limited, will be far from a really true understanding. On the road, still looking at topics like uploading consciousness, deep learning, temporal consciousness, the philosophical discussion of time, more on current memory research, and then adding one, the external world as illusion, which has become rather widespread. The idea that, for example, everything we've just talked about, from radios, transmission lines, and in the backhoe, are really just creations of consciousness and don't have independent physical existence. In other words, a massive return to idealism. And I guess one can imagine what Bergson might say about this, but it'd be interesting to go into. And then something else is possibility. So next time, we'll see. Until then, signing off.